This is a 1 kilogram chunk of bismuth that I bought on eBay. Now you can see at the moment it's very, very shiny, but once you heat it up, it will start to oxidize on the outside. One of the cool things about bismuth is that you can actually melt it in a saucepan on a hot plate, and you don't need a furnace or anything to reach extreme temperatures like you do with most metals. It produces these strange geometric crystals when you leave it to cool down. To make them, what you have to do is let it cool gradually and then pull out the crystals from the top and sort of shake off the liquid bismuth and, try not to make a mess of it. And you get these really nice little crystals. Now, these ones are actually really, really small compared to what you can get if you have a big load of bismuth. Like, if I had like 5 kilograms of bismuth, I'd be able to make fist-sized ones, I imagine. But I don't really want that much bismuth, to be honest. If you look closely, you can see that they have these little stair-step patterns, and that's typical of bismuth crystals. And the rainbow colours, the iridescence on the outside, is caused by the bismuth oxidizing in the atmosphere. If you pour molten bismuth directly into water, for example, you won't see this iridescence pattern because there's no oxygen available to oxidize the bismuth. Here are some close-ups of the bismuth crystals. Here I've got a pot of bismuth that I'm stirring up with a bit of old copper pipe. And you can see that as I stir it up, the molten bismuth at the bottom, the unoxidized bismuth, comes up. But then as I leave it, the air starts to oxidize the surface, and you can see that the color begins to change from a sort of goldy silver color to a nice blue color. You can see here in this small pot what happens if you pour the bismuth in and you give it a very short time to cool down before pouring out the excess bismuth. You get very small, numerous crystals with the same rainbow iridescence. After playing with the bismuth for a while, I thought, what would happen if I was to dip a rod into the bismuth over and over again? So similar to how you make a candle. So if you've ever seen a candle factory, you take a wick and you dip it into the molten wax, and then you pull it out and then you let it cool down, and then you do the same process over and over again, and eventually you get a candle. So to test this out, I needed to build a machine that would allow me to actually repeatedly insert a metal rod into the bismuth in a controlled way. So I designed this machine, which is very simple. It's just a stepper motor connected to a piece of string, connected to 2 rods that can slide up and down. And the reason for the string is so that it can pull up with some force, but it can't push down and knock the pot of bismuth all over me. At the bottom of that, you can see there's just a rod with a heat sink on there, just to dissipate a little bit of the heat from molten bismuth. The first experiment I did was to just repeatedly drop the rod inside the bismuth and then pull it back out and then drop it back in without any increase in height at all. And I think it was about 2 seconds delay between the drops. And this produces a very strange onion layer effect to the bismuth that you can see here. You can barely see any crystals at all, any normal bismuth crystals, because each layer is so thin. This next run, I increase the height by about 0.5 millimeter every time, and it produces a similar result but with an interesting sloping effect as it goes down. If you change the settings enough so that there isn't enough time to form a smooth layer on the bottom, it actually creates these strange stalactite-type dangly bits of bismuth that hang down from the main lump. And they can grow very long, but they're very, very fragile. Any sort of slight movement and they'll just fall off. And I think they're largely oxide, but they do have a core of bismuth in there. It's very interesting the way that they come out. This is a similar run where I left the mass to grow to a substantial size. One of the strange things about the stalactite formations is that the iridescence is very hard to capture on camera. Looking at them in person, the iridescence is very clear, but essentially vanishes when you try and capture it on video. The final appearance of the dipped bismuth lumps is very dependent on the temperature of the pool of the metal and the time that you allow it to cool. Here's an example where it formed into a somewhat uniform cylinder shape as the crystal was pulled upwards. One of the nice things about working with the bismuth is that you can just remelt it when you're done with it and then use it for something else. Because it has such a low melting point, you can actually pour bismuth directly into aluminium foil. So you can make a mold out of aluminium foil off of any object, and then you can just pour the liquid bismuth straight into it. Eventually the outer shell of the bismuth starts to cool down, and if you pour that liquid bismuth straight out again, you'll leave this really interesting geode cavity with this iridescence that's really nice. And the aluminium doesn't even stick to the outside of the bismuth at all, which is really good. You can see on this one, the bismuth has started to crystallize upwards from the base of the mold and produce some really interesting protrusions. Around the outside of the cavity, you can see these cubic crystals forming and the broken, fragmented oxide layer, and it produces a massive range of colors. The bismuth captures lots of detail from the foil itself, so if you were doing a casting using this, you'd be able to capture some really nice detail and make some very interesting cavities on the other side. Here's a selection of some of the more interesting ones that came out of the casting process. Okay, that's everything I've got on the bismuth. Thanks for watching.